To remind you what a vector looks like.
A vector or a line?
Well, that's a vector.
Yeah.
These are vectors, so that's a vector. But yes, this one is a straight line. How do I know it's a straight line?
Because you got okay.
No, that would mean it's in 3 dimensions.
Wait, are we doing? Oh.
2D and 3D, I don't care anymore.
How do you know it's what?
How do I know this is a straight line?
Because there's no squares.
Correct. There's no funny functions. It's just linear. Linear, linear, it's a line. You've seen this before. We have done the conversion from this to Cartesian. Do you remember how to do it?
Yeah.
Mm-hmm.
Go. Show me. I'll give you a hint.
You win. I don't need anything. That's okay, sir. Oh.
That's your hint.
Did you get it?
Yep. I've got a magnetic phone case. Or remember vaguely how to do that? Yes? Yes? Okay. Ben and Joy, you're okay?
Yeah.
Okay. So you can take one, if it's in 2 dimensions, you can turn it into a 2-dimensional thing. And, do a Cartesian equation. Vector parametric, Cartesian. Only things here, only variables here are x's, y's, and maybe z's. That would make it Cartesian. In a 2-dimensional case, it's now assumed knowledge because it was unit 1. You have to be able to convert a 3-dimensional thing that happens to be 2-dimensional into a Cartesian equation. You can't always do that. I could give you one with 3 dimensions with funny functions. There's no way you can turn it into a 2-dimensional thing. And it's very difficult. In general, it's very difficult to make a Cartesian equation. But straight lines you can. Do you want me to give you a harder one for practice? Let me try another one you have again done before. So I've given you a domain for the parameter. Turn that into Cartesian for me, please. And if you're game, sketch it and indicate which bit of the shape I'm talking about.
Why did you give us the domain?
Because this Cartesian equation describes a shape on the plane, but I only want some of that shape.
Isn't the whole thing inside that domain?
No. If t is greater than or equal to 0, right? So 1 minus x is greater than or equal to 0.
Oh,
Negative x is greater than or equal to negative 1, which means x is less than or equal to 1. So I only actually want the left half of this parabola.
Oh.
Remember doing that?
I was thinking t as y.
No, t is not y. T squared is y.
Yeah.
There's my parabola. But I only actually want from this point in this direction, not this bit. Including, so it's a filled circle. Same convention as you've always used. I assume you've always used that convention before.
Mm-hmm.
Okay. All right. Our dot point says, understand and use position of vectors as a function of time. Understand and use the Cartesian equation of a path, given as a vector equation in 2 dimensions, including circles, ellipses, hyperbolas. So we're going to get to circles, ellipses and hyperbolas in both vector form and the Cartesian forms which are on there.